down glucose. So we have glucose right here, and it's energy rich in the cytoplasm. There's only one. And so there's 3 different steps in respiration that we're gonna go about, and it's gonna all go in order. So we're gonna start with glycolysis, Krebs, and then ETC. So glycolysis, you're gonna have to just memorize this. 2 pyruvates, there's 3 carbons, 2 ATP, 2 NADH. So that's glycolysis. And then you're moving on to the Krebs, or the transition phase, and each pyruvate turns into acetyl-CoA. And then just memorize this as well. 6 carbon dioxides, 2 ATP, 8 NADH, 2 FADH2. And the end product of Krebs itself is carbon dioxide. Honestly, I just kept looking at this and I just remembered.
And for the Krebs cycle, always remember that it goes around twice.
I was just gonna say that.
Yeah.
So,
yeah.
and then
Just think of it like a little, I don't know, like a,
Yeah.
it's going around.
There you go.
You know?
That's like, actually that's good.
Yeah.
That's good.
yeah, and then for the Krebs cycle though, the end product, it gives off CO2
Yeah.
a lot sooner or something like that.
Yeah,
she
just
said.
for the Krebs.
Why
And
do
you
you
get
have the arrow going over from Krebs to 8 and 8?
just those are what's
Oh.
happening in Krebs. Oh, he means an 8
Yeah.
NADH.
Yeah, it's the same
Um,
thing. Okay. And then after Krebs is ETC, electron transport chain. You're going to have 10 NADH because you're adding from the first and the second ones to get 10, and FADH stays the same. So you're moving into the plasma membrane in the ETC, so always remember that. You're not in the cytoplasm anymore. You're in the plasma membrane. And so you move over to the chain right here, and on the outside of the plasma membrane there's a bunch of protons, aka hydrogens, and on the inside there's a small amount of protons, and there's a positive motive force, which is the potential energy. So in the beginning of the chain it's high energy, and then at the end it's going to be low energy. And so it has a bunch of pumps, and the hydrogen's going to go through these pumps to go outside of the plasma membrane. And as the high energy goes towards the end of the chain, all the electrons are basically losing their energy, aka getting low energy. And then you end at the ATP synthase, which is like a bodyguard, and it's just going to be like, oh, hydrogens, you want to come back inside? Okay, I'll let you come back inside. And then that's into the plasma membrane. And then you're going to end this electron transport chain with oxygen. Okay.
Okay.
And then going back, our oxygen is our terminal electron acceptor. So that's what we ended with, and that's what, I guess, that's what it equals. And then your end product is water. So after that, it's water. And this was all aerobic. So glycolysis, Krebs, and then ETC, it's all going to equal water. This is what it all made. And it's going to equal 38 ATP.
So this is all one thing.
Just
Yes,
one side.
Like
of
it has
yeah.
to go through glycolysis, Krebs, and ETC.
Yeah,
Except
and that's
from
the-
water.
Yeah,
Mm-hmm.
just for water.
Mm-hmm.
That's all
Yeah.
it is.
Aerobic.
Yeah,
Yes,
Yeah.
aerobic.
because it uses O2.
Yes.
So my only question is, you see the 8 the 8 NADH over here holding the little electron things?
oh,
8
yeah.
NADH and 2 FADH?
Yeah.
Is that part of anaerobic too?
Yes. Yeah.
So
that's what
this
she's
whole
doing.
process of the 2-pyruvate, that happens in anaerobic and aerobic?
That's what I'm thinking, because when she was
You know what
doing the
I'm
lecture,